So I don't know if you noticed, but there's a lot of limits and infinities floating around in this section, which means we need to be on guard for L'Hopital's rule. Now, L'Hopital's rule gets used with indeterminate forms, such as 0 over 0 and infinity over infinity. And then there are also these other indeterminate forms, infinity minus infinity, 0 times infinity, 1 to the infinity, infinity to the 0, and 0 to the 0, even though that looks really tiny, but it's 0 to the 0. Those ones all have to be manipulated so that you can use L'Hopital's rule. And just also a quick reminder of ones that are not indeterminate. We know what these are. K over 0 is either infinity or negative infinity, or both. It could be nothing. K over infinity is always 0. Infinity plus infinity is infinity. Negative infinity minus infinity is minus infinity. 0 to the infinity is 0, and 0 to the minus infinity is 0. So all of those were covered in section 4.7, which we snuck in before this section, so that must mean that it's useful, right? And it is. All right, so we're going to do this problem, and this is going to require a couple things, actually. So I'm going to take the limit as, I'll go back to b. As b goes to infinity, of the integral from 1 to b of x times e to the negative x dx. Now, if you're savvy and paying attention, you might realize, oh, that's multiplication. Product. The only way to undo a product in an integral is integration by parts. So we need to use integration by parts. So u is equal to x, right? Lip it, you go with your polynomial. So x du is dx, right? Because the derivative of that is 1. dv is e to the negative x dx. So therefore v is negative e to the negative x. All right, so we need to change this out by parts, this piece. So I'm going to write it as the limit as b goes to infinity of, okay, so then it's negative x times e to the negative x, right? Because it's uv. So these two multiplied. I'm going to take that from 1 to b plus integral from 1 to b of v du, which is negative e to the negative x dx. So all of that got put in there. So I had to use integration by parts. Hey, that was fun. All right, but the integral of negative e to the negative x would just be, oh, it's minus a minus, rats. Hold on, sorry. It's minus, here, it's minus a minus, right? Because it's minus the integral of v du. I apologize. So that would make it plus, right? So I'm going to write the limit as b goes to infinity, and luckily for me, this is actually going to work out, and I can just leave 1 and b alone. So it's going to be negative x e to the negative x minus a minus is plus, but then when I integrate, it'll be a negative again, right? Because the integral of e to the negative x is negative e to the negative x, see right over here. And then we don't need to worry about a plus c because this is not in an indefinite integral. It's an improper integral, but not indefinite. And we're going to take that from 1 until b. Okay, well, before I start substituting values in here, I think it would be wise to factor out that e to the negative x, because that could come out. So that would be the limit as b goes to infinity. And then I'm going to factor out, actually I'm going to factor out a negative e to the negative x. And then that'll leave me x plus 1 right here, because I factored everything out, so there's a 1 in there. I don't know if this was strictly necessary, but it just seemed to me like it would be a little bit easier. Okay, so then I'm finally to the point where I can substitute and put b in and put 1 in and then take the limit. So this is equal to the limit as b goes to infinity of negative e to the negative b times b plus 1 minus, and then negative e to the negative 1 times 1 plus 1. Alrighty. Okay, so this value over here on the left, if I put infinity in, just think about this for a second. If I put infinity in, I would have e over, well, it's 1 over e to the infinity. I mean, it's negative, but what difference does it make? And then times infinity plus 1. That's 0 times infinity. That is one of our indeterminate forms, right? So this one right here, this part is indeterminate. Not so for this. This is actually okay because this is just 1 over e times 2, right? So this is constant over here. So this part is indeterminate. This part is a constant. So it's not going to be in the limit anymore. We're actually going to take it out. All right, so we're taking the limit as b goes to infinity of, I'm going to rewrite this just a little bit. So this is b plus 1 over negative e to the b, right? Because when we move it down, then it's going to go like that. And then we're going to stop the limit part there, because over here we're actually going to figure out what this is, because this is just a constant, right? This is not even involved with the b at all. There's no b in this. So it's plus 2 over e, right? Because a minus makes plus. That's 2 right there. And then this e to the negative 1 is over e, right? All right, so now what form have we got? So now if I put infinity into this one, my form would be infinity, because infinity plus 1 is infinity, over negative e to the infinity. E to the infinity is infinity. So that's perfect. Yay! We can use L'Hopital's rule. Hurrah! That's wonderful. All right, so then that means that by L'Hopital's rule, this is equal to the limit as b goes to infinity of, and we take the derivative. The derivative of this is 1. And the derivative of negative e to the b would be negative e to the b, right? The derivative of e to the b is e to the b, and then it's just multiplied by negative 1. And then this whole thing is plus 2 over e, because that's a constant. That's not involved with the infinity part at all. So we just kind of leave it hanging there. But this is no longer indeterminate. I can put infinity into this. This is 1 over negative e to the infinity plus 2 over e, which is 1 over infinity plus 2 over e. And 1 over infinity is 0. So that means that my limit is 2 over e. Now I'm going to teach you a way to check this a little bit in Desmos. All right, so this was a definite integral, right? But Desmos doesn't handle infinity very well. Now I can see my curve is right there, and I can see the area that I'm shading, right? Is from 0, which is less than or equal to y, which is less than or equal to f of x, and x has to be greater than 1. No problem. My cheeky way of getting around the calculations. So I let it go from 1 to a, right? And you can put b, you can put t, you can put pretty much whatever. So if we look at the one we just did, it was b. So I'll use b. Tomato, tomato, right? And then I just let b get really large. I mean, I can't get it, to infinity or anything, but I can get it, very, very large, and I can affect that integral, right? So that integral from 1 to b of that function as b gets larger and larger, and you can see that it's the same as what 2 over e is equal to. It's kind of a workaround because the calculator, the Desmos calculator, cannot handle infinity as a symbol in here. So it won't do infinity in your integral. However, you can check yourself this way and just let your slider bar get really big and it should work. And just so you can see it there, I put in infinity and it doesn't do anything. It doesn't like it. It has to be finite numbers for the limits of integration. So fine, I'll just put in a constant and make it a slider and it'll work. Sneaky, huh? Oh, the one other thing we want to mention is this is convergent. We asked in the instructions to label it as convergent or divergent, and it is definitely convergent because it's converging to a finite value of 2 over e, which was about 0.7 and some change.